So this is LeetCode 94, binary tree Inorder traversal. So here we're given the root of a binary tree and told to return the in-order traversal of its values. So the in-order traversal of a binary tree would basically be getting the farthest left value and then getting the root value and then the right values. So let's just say we have this tree right here. So the in-order traversal of this would go like this. We start at 1, and we basically go all the way left till we can't. And then we do the root node, then the right node. And we add all those values each way to the list. So we'd go left, then left. Now here, this is a 3. When we're here, there are no more nodes to go to, so we add the 3 to the list. And we backtrack to its root, which would be 2. And then we get the right node, which would be 4. And then from there, we go to the next node, which would be the root, which is up here. Then we go to that right node, which would be 5. And basically, it's just a recursive function that is checking each tree like that. So to do so, you could have do like pure recursion with like a separate method. I just found that to be a little weird because we're adding it to a list. So here we're going to want to first get a list of integers. We're going to want to instantiate that. So we're going to basically do a recursive function within this one. It should be pretty simple. But from here, we're going to want the base case, because when you do recursion, you always need a base case for when it should end. So we're going to do if the root is null. I'm just going to return the list, the empty list. And now from here, we're going to want to do the traversal. So the left, and then the node, and then the right. So we're going to want to start by checking if the current node we're at has a left value. So if the left value is not null, that means that it has a value. And so here we're going to need to add all the next values to our list. So this add all method is part of the collections library, which is also part of the list and array list data structure, you could say. It's really useful, but basically it's just adding from this array list, it's adding all of the values in this list, because this is going to return a list. It's basically adding all of this list values into the current list. So from here, we're then going to want to just add the current root. And then we're going to want to do the right values. Just the same exact way. And this seems correct. I believe this is it. I gotta capitalize that. And yeah, so fast runtime, fast memory.